then we're going to do probability, and then we're going to do independent events. So there's a whole bunch of stuff that they're all kind of combining into this one thing. We've definitely done some of this since pre-algebra, so hopefully some of it looks familiar to you guys. The first fundamental counting principle: if one choice can be made in A ways and another choice can be made in B ways, then the number of possible choices in order is A times B. All right? So this will make more sense when we do one like this. There are 3 chairs in a row, and there are 7 students. How many ways can these students sit in the 3 chairs? So we have 3 chairs all in a row, all right? And so for the first chair, if we start here, how many different people could sit in the first chair? 7, all right? So then we put somebody in the first chair, right? So someone sat down. So now how many people can sit in the second chair? 6. Okay, now 2 people have already sat down. So how many choices do we have for the third chair? All right, so it's just 7 times 6 times 5. All right, so it's always like 1 less because somebody sat down. And then, so whatever that is, you guys, anybody got that? What'd you get? Okay, 210. All right, how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted? Okay, the actual numbers don't matter. So it doesn't matter that it's 3, 5, 7, and 8. You don't ever plug those in, okay? They don't matter. What matters is how many different numbers do we have. All right, so there's 4 different choices, and we want to arrange them in order. So just like we were sitting in the chairs. So I have 4 spaces, okay? Just like the last problem. So there's 4 different numbers. How many numbers, choices, do I have for the first spot? 4. So maybe we're like doing a lock, like some code, right? And these are the different ways we can put the numbers in that 4 different places. So 1 goes in the first place, and then we put 1 here. So now how many choices do we have left? 3. Now we have 2 numbers already placed. How many choices do we have left? 2. And the last one would be, there's only 1 number left after we placed all the other 3 numbers. So 4 times 3 times 2 times 1. Brendan, what's that? What'd you say, 24? Okay. All right. So this one's different because repetition is allowed. In the last one, we couldn't repeat any of the numbers. So for this one, how many 4-letter signs can be made from the letters in the word equal if no repetition is permitted? So really, all we care about is how many different letters do we have in the word equal. Okay, there's 5 letters. So how many 4-letter signs? So we're making 4-letter signs. 1, 2, 3, 4. So there's only 4 spots. This time we can repeat letters. So we could actually put E, 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 Q, Q, E, right? Like there's all kinds of combinations. And repetition is permitted. So how many choices do I have for the first spot? 5. How many choices do I have for the second spot? 5, because repetition is allowed. How many for the next spot? 5. How many for the next spot? 5. So that's how many choices we have if we're allowing repetition. So total, that would be 625 different ways that we can arrange the letters equal if we can repeat letters, okay? Okay, so this one you guys have been doing forever. This is really easy. So what's the probability of rolling a 5 on 1 roll of a die? What do you guys think? 1/6. All right, so that's pretty awesome. 1 out of 6. There are 6 sides. So 1/6. Okay, Roger rolls a pair of dice twice. What is the probability that in 2 rolls he will get a total of 7 on the first roll and a total greater than 9 on the second roll? We're combining a couple things here. First thing you have to know is we're rolling it first 2 dice, and we're adding the dice together, right? Whenever you do sum of dice, if you guys had me last year, I made you write this chart out every single time. Do you guys remember that? Some of you guys remember? Okay. So, you should definitely write this in your notes. So you roll 2 dice, and we have a 1, a 2, a 3, a 4, a 5, and a 6. And the other dice has a 1, a 2, a 3, a 4, a 5, and a 6. So if we roll a 1 and a 1, we get a 2. If we roll a 1 and a 2, that makes 3, etc. Alright. So whenever you're doing sum of dice, make sure you guys write this out. Yeah, I know. Every time. Otherwise, you're going to forget. So how many different choices do we have anyways? Yeah. So these are always out of 36. So if you guys ever go to Vegas, what number is most commonly rolled? 7s. All right. 7s. 2 and 12. Not so much. Don't bet all your money on those. All right. So what is the probability that in 2 rolls, so this time I have 2 things happening, and we're going to multiply our 2 rolls together. So he will get a total of 7 on the first roll. So for the first roll, a total of 7 is 1, 2, 3, 4, 5, 6. There's 6 out of 36. So 1 in 6 chance of getting a 7 on the first roll. And a total greater than 9 on the second roll. So greater than 9 would be getting a 10, 11, or 12. So how many choices is that? That is also 6 out of 36. So if we reduce, that's 1/6 times 1/6. So a 1 in 36 chance that you're going to get a 7 on the first roll and a number greater than 9 on the second roll. So if there's more than one thing, multiply your choices together. And here's another easy one. A fair coin is tossed 3 times. What's the probability it comes up heads every time? So 3 times. What's the probability of getting heads? 1/2 times 1/2 times 1/2. So the probability of getting a heads 3 times in a row is 1/2.